Hi there, welcome to a video outlining genetic inheritance with sex-linked traits. So it still follows that basic Mendelian model of dominance and recessive inheritance, and we can use a Punnett square, but it's going to be really key for us to track where the alleles are and what different combinations give you certain phenotypes, because that is greatly impacted in sex-linked traits. So in sex determination, the X combination is going to give you female, and then the XY is going to be male. Now the Y chromosome, so typically when we've drawn chromosomes, we put them in an X type conformation. The Y chromosome is a little bit smaller, so it doesn't have quite as much genetic information. It's really devoted to sex characteristics. So the Y chromosome is devoted to those sex characteristics. Where the female X chromosome, because it's a bit larger, it also can code for sex characteristics, but then it carries additional traits as well. So what ends up happening is the X chromosome can contribute traits that the Y chromosome can't. So that's going to impact how different traits are inherited between male and female. So we can still set up a Punnett square, but it's going to be extremely critical, and I really try to always emphasize this, is to have a good legend of what the different combinations can be. So I'm going to use another one of my hypothetical setups here. And I'm going to say that the genotype XT is going to be a female that shuts the toilet lid. So if you live in a house with men and women, you know this can be a point of contention. So we use this as kind of a fun example. But also, because this particular trait that we made is dominant, this allele, if you have a heterozygous combination, so this is homozygous over here, and this one's heterozygous, you're going to have also a female that shuts the toilet lid. Okay, there is a possible combination for a female that does not. And this would be a female that doesn't shut the lid. Okay, so again, going back to that idea of the X chromosomes can carry additional genetic information, the Y chromosome does not. So it's almost kind of for that particular allele, a blank right there. So for the males, the combinations are only carried on the X chromosome. So you can have the dominant, so this would be a male who shuts the lid. And then you can have a male that does not. So what you see here is you have two different possible combinations that can give you that dominant trait in females. In the males, it's a 50-50 chance. So over populations, over families, you're going to see that the female is going to inherit that trait much more commonly than male. And then the classic example that's used is color blindness as well in males and females. It's not that females can never be colorblind. It's just that there's only they'd have to have, there's only a 1/3 possibility there of even if all the alleles are even present of inheriting that, but then they would have to have a mother and a father that can contribute those color blindness alleles. Where the male, again, because the X chromosome is what's going to determine that particular trait, whatever the mother contributes is going to be what's expressed. So there's nothing to mask it, if you will, because there's not two sets of alleles for that particular trait. And this is only seen in the XY, the sex-linked traits, because all the other chromosomes, the body chromosomes, those all have 2 copies of each allele. Okay, so we can set this up and then determine genotype and phenotype. So let's see, make it a little bit interesting. We'll take a female that's heterozygous again. Now her phenotype, this mother, is going to be, again, you gotta have that legend there, is gonna be that she shuts the lid. The father, we'll use, and we'll make him carry one, so he doesn't shut the lid. So again, you would have to go to your legend for that. So we're going to have different combinations. There's two things we're tracking here. We're tracking sex, and then we're tracking, we're tracking that particular trait that's there. Let me correct that. So we've got the XT here, and the X lowercase. And we could use, again, those colorblind alleles, and you would see this here as well. The male could have the mother's X here, or this possibility for the mother's X. Now in this case, we're actually going to see a 50-50 combination, which you don't see very often unless the mother is both carrying the trait and the father has the trait. So the likelihood of that occurring is relatively small. But you would get 25% of the daughters. That's our XX, just to remember. Close the lid or shut the lid. 25%. And this is, again, just predicted possibilities. Could you have, if you have a family, 4 boys in a row that all close the lid? Yep, you could. So these are just predicted possibilities, but they tend to map the patterns fairly well. But sometimes in small, small groups, statistically, you don't see that as much. So 25% of daughters, and let me track these over here. Whoops. 25% of daughters don't close the lid. And then you're going to get 25%. So it's just the interpretation's a little more complex. As long as you have a good legend, you're going to be okay because you can go back and match that up. 25% are going to be males that close the lid. I'm getting really abbreviated here. And then 25% are going to be males that don't close the lid. So again, key to have an important, really key to have that legend there and to refer back to it. When I see students skip that step, they do all this really beautifully, and then they make missteps when they go to the interpretation here. So again, this is kind of a fun trait to use. It's a hypothetical trait. But if we were looking at a disease trait, so for example, like Duchenne's muscular dystrophy, and the family knows that somebody's carrying that particular allele that can cause disease, they're going to be very interested in these ratios that come out, and if it's sex linked, boy versus girl, all of that will give them information to make decisions there. Okay, so that's what I have for genetic inheritance. Again, this can be used in calico cats, it can be used for color blindness, so you see it with different applications. I've just given you a hypothetical one here. I thank you very much. Please contact me with any questions. This is Corey Andres at CNM using CNM Glass.